All right, in our talk about distributions and how a distribution uh, is a shape of the data, um, the shape can have certain properties to it. And one of those properties is symmetry. So an object has line or mirror symmetry if a line can be drawn which divides an object into two mirrored images of each other. So you can see in this first example, I've got a square of a wallpaper pattern, and you can see it has a line of symmetry right down the middle. So it's the same on the left-hand side of that line of symmetry as it is on the right-hand side. You'll notice that the line of symmetry doesn't go this way, right? Because if it did, you would see this red flower mirrored on this side. And you would see these two yellow flowers here and here mirrored there and there, right? So this line of symmetry is clearly going from the top down. Now here's the hallway, which looks like from the inside of a church, old medieval church, and you see it's got a line of symmetry right down the middle of this image. It's the same on the left-hand side as it is on the right. And here's the image of a cat. The line of symmetry is right down the center of its face, or right down the center of its head from top to bottom. And you can see if you were to take what you saw on the left, flipped it over, you would have mirror symmetry on the other side. All right, so this, might be easier for you to relate to as far as when we talk about symmetry and a line of symmetry. Now, let's bring this to statistics. So let's consider these two random variables. We have random variable y, which represents parental sleep time in hours. And we can see down here, here's random variable y, which represents parental sleep time. And then here's all of the parents who were asked how many hours of sleep they get each night. All right. Let's see here. I didn't put the sample size on that one. How many do we have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so there were 24 adults, and they were asked how many hours of sleep that they get each night. Okay, and that's the recording of all 24 adults. Now, if you take that data and you graph it, then you get a histogram. And so down below, this is a histogram of parental sleep time. And you'll see that it has a distribution shape as well. Something like that. And it has a line of symmetry right down the middle. It's the same on the left-hand side as it is on the right-hand side. All right, so this is an example of a symmetrical distribution, and a way to, remember symmetry is actually just to look down at your feet, and if you imagine a line going down between your left foot and your right foot, you'll see that, you go from big toe, second toe, third, third. So your feet are mirror images of each other, right? Just like that. Now, a different kind of distribution other than this type of symmetrical distribution, this is called a normal distribution, is we can have one that's called a uniform distribution. Now, this is also symmetrical. So if we have random variable W, which represents lab rat sleep time, okay, here's W, here's all 21 rats with their recorded sleep times. And if we graph that data, then that's histogram W, okay, the histogram of lab rat sleep time. And you'll see instead of having this uh, this curving distribution shape that kind of comes up in the middle and then comes back down on the sides. This one is flat all the way across. So it's a horizontal line. Now, this is a different distribution shape, but it too is symmetrical. Because if you were to draw a line of symmetry down the middle, okay, it's the same on the left-hand side of that line of symmetry as it is on the right-hand side of that line of symmetry. Now, by coincidence, I mean, these two distributions, have lines of symmetry on x equals 7. Line of symmetry, x equals 7. All right. So I think, yes, that's going to pretty much define what we mean by symmetry and how you have a line of symmetry and how that translates to statistics, where I've got two examples of symmetrical distributions. One would be something called a normal distribution, and then another one called a uniform distribution. All right, let me know if you have any questions.